Welcome to Organic Chemistry Lab at Nazareth College. Today in the lab, we will be doing a nucleophilic aromatic substitution experiment, or NAS.
In this reaction, a nucleophile attacks an electron-poor aromatic molecule, resulting in the substitution of a leaving group. The rate-determining step is attack of the aromatic ring by the nucleophile, which disrupts the aromaticity, forming the Mesenheimer complex. The electron withdrawing groups on the aromatic ring stabilize the negative charge of the intermediate and therefore make the ring more reactive. For our reaction today, we are going to be using 1-bromo-2,4-dinitrobenzene as our electrophile, and our nucleophile is going to be aniline. The three requirements that must be met for nucleophilic aromatic substitution to occur are: the benzene ring must possess strong electron withdrawing groups on the ring, for example, our nitro groups. Second, the ring must possess a good leaving group, so we have bromine. And third, the leaving group must be positioned ortho or para to the withdrawing group, and we have that as well. And shown here is the product of our reaction, 2,4-dinitrodiphenylamine. Okay, that's enough theory. Let's head to the lab.
To begin this experiment, you're going to obtain a clean microwave glass reaction vessel, a vent plug, a small magnetic stir bar, and a vessel top. You'll place the magnetic stir bar into the vessel. Now you'll obtain the compound 1-bromo-2,4-dinitrobenzene and weigh out 0.296 grams of this compound. You will add the 0.296 grams of this compound to your reaction vessel. Now you will obtain 0.440 milliliters of aniline and add this to your reaction vessel. Finally, you will obtain ethanol, and you will measure out 5 milliliters of the ethanol and then place that in the reaction vessel as well. Now you will place the vent plug on the top of the vessel and the vessel top, and at first finger tighten the vessel top to the reaction vessel, being sure not to over tighten it. Now you will obtain a torque wrench, and using the torque wrench you will tighten the top of the vessel till you hear a click. This is what the reaction mixture looked like going into the microwave. The reaction vessel is then placed in the microwave where the reaction will occur. Once the product is cooled enough to be taken out, the product is placed in an ice bath to assist in the formation of crystals. This is what the product looks like once the crystals have formed. Now, since crystallization is complete, the product can be collected by vacuum filtration and washed with cold ethanol to make sure all the product is collected. After all the product is transferred into the funnel, allow it to sit for a bit to dry, and this is what the product looks like once dry. Now transfer the product that you've collected into a tarred weigh boat, and then once it's all collected, making sure to transfer everything from the funnel and the filter paper. Weigh the final product to obtain the mass. This is the mass that was obtained for the product.
Determine the melting point of your product and take an infrared spectra of your product.
Now we will do a TLC analysis of the product. To begin, you will take 2 pre-cut TLC plates and gently place 4 evenly spaced pencil marks about 1 centimeter from the bottom of the plate. You will be given a small vial that contains 1 bromo-2,4-dinitrobenzene dissolved in ethyl acetate and a small vial of aniline dissolved in ethyl acetate. Now you will spot your starting materials and product using capillary tubes. On marks A and D, you will spot the 1-bromo-2,4-dinitrobenzene starting material, and on marks B and D, you will spot the aniline starting material. Then, on marks C and D, you will spot your product. In order to be able to spot the product onto the TLC plates, the solid needs to be dissolved in a bit of solvent so that way it creates a liquid that can then be spotted onto the TLC plates. Now you will take the TLC solvent, which is 40% ethyl acetate, 60% hexene, and place about 1 milliliter of the solvent into a tall 100 milliliter beaker. Now you will place your TLC plate into the beaker, making sure that the solvent in the beaker does not go over the pencil line at the bottom. This is what the TLC plate looks like during the process. This is what the plate looks like once the TLC is complete. In order to see all the spots on the TLC plate, it needs to be placed under UV light. All the spots that are visible should be circled with pencil. And now it's time for Safety with Jane.
Subbing in for Jane is Dr. J. Charleboy.
Okay, here's your safety tips for the day. Do not look directly into the UV light. Dispose of all glass waste in the cardboard glass waste only container. The capillary pipettes that are used can be placed in the labeled beakers around the lab for that purpose. Hexanes and ethyl acetate are flammable, so don't light them. All waste goes in the liquid waste container, not down the drain. 1-bromo-2,4-dinitrobenzene is classified as an irritant, so use caution with that. Now, go to the lab and be smart. Easy peasy.
There you have it, nucleophilic aromatic substitution. And a great big shout out to Allie for all the great work in making this video.